Hello, my name is Brian Jottis. I'm a Senior Design Engineer for the Mixed Signal Products Group at Linear Technology. Today, I'd like to talk about isolating high-resolution SAR analog-to-digital converters. In many industrial or test and measurement systems, isolated data acquisition channels are essential. It may be needed for equipment or user protection, or to measure signals in the presence of large common mode voltages or transients. Successive approximation register analog-to-digital converters make up a significant part of the market in the 100 kilosample per second to 5 megasample per second data acquisition space. As the resolution and speed of SAR ADCs increase, the speed of the communication port must likewise increase. Many of Linear Technology's 1 to 5 megasample per second SAR ADCs support 100 megahertz SPI ports with up to 24 bits of resolution. Isolating the communication port becomes especially difficult at 100 megahertz. The LTM2893 drops in between a microcontroller, ASIC, or FPGA on one side and the ADC on the other side, enabling full 1 megasample per second or greater data acquisition. The LTM2893 works with any ADCs operating in SPI mode 00. The SPI S clock is dedicated to the SPI port operation, and the S clock frequency of the ADC is in the range of 6.25 megahertz to 100 megahertz. Designed with Linear Technology's proven micromodule isolation technology and high-speed processing, the LTM2893 enables a full 100 megahertz capable SPI port along with SAR ADC control signals. It processes the equivalent of 9 isolation signals supporting read-only ADCs. This includes a low jitter conversion start signal and a conversion busy signal. For configurable ADCs like the LTC2348, the LTM2893-1 adds a write channel across the isolation barrier for a total of 10 signals. Competitor solutions would require multiple digital isolators to accommodate all of the necessary signals. Furthermore, no competing product operates close to 100 megahertz. Let's look at how limiting the standard digital isolator can be in the application we're discussing. Standard digital isolators transfer every input edge event from one side of the isolator to the other. Every transfer has a propagation delay. Even products specifying 150 megabits per second have propagation delays of as much as 14 nanoseconds. Let's see how they add up. During a SPI read, summing up, the S clock propagation delay to the isolated side ADC, the response of the ADC, the meso data to transfer back, and the setup time requirements result in lowering the maximum S clock frequency to approximately 25 megahertz. Other competitors' methods feed back a delayed version of S clock to the master to clock a receiving meso register. This approach requires a custom SPI port implementation. Existing examples of this method are generally limited to a maximum S clock frequency of 40 megahertz. In contrast, the LTM2893 uses built-in functions to track and set the proper signaling on each side of the isolation barrier. The LTM2893 transfers only the important information, significantly reducing the data across the isolation barrier. The LTM2893 initiates a conversion with the conversion start signal and then monitors the ADC busy signals to track when the conversion is complete. Once the ADC control signals are satisfied, the isolated side operates as a master SPI device to fetch the serial data from the ADC and transfer it across the isolation barrier into a FIFO. Once 2 bits of data are stored into the FIFO, the logic side will release its busy signal and operate as a slave SPI device to allow the master to retrieve the data from the FIFO. With this method, only data values are exchanged across the isolation barrier, allowing the SPI clock to run much faster, up to 100 megahertz. The LTM2893 has 2 read channels, meso A and meso B, each of which will support its own ADC. Both ADCs will be read simultaneously without any throughput penalty. The SPI clock frequency into the ADC is configurable along with word lengths and word counts via configuration register. The ability to adjust the word lengths and word counts enables chaining of up to 4 ADCs on each meso pin. Default word count of 1 a word count of 2, word count of 3, word count of 4 for a maximum of 8 ADCs. This is the FFT of the LTM2893 with an LTC2338 18-bit SAR ADC capturing a 10 kHz input tone at 1 megasample per second. Due to the low aperture jitter of the LTM2893, we achieve a signal-to-noise ratio of 100 dB. This performance metric is nearly identical to the standalone LTC2338-18. In this last application, the select signals SA, SB, and SC control an analog multiplexer. These signals can also be used for gain selects or ADC control signals. Additionally, the LTM2893 rejects common mode transients greater than 50 kilovolts per microsecond even during the transmission of data. If a substantially faster transient occurs, a fault pin will signal the possibility of data loss. By focusing on isolating an ADC, the LTM2893 excels at delivering the full sampling rates of general-purpose, high-resolution ADCs. It simplifies the interface and the communication to maximize performance and minimize component count and PCB area. For more information, please go to linear.com. Thank you.